Now we're done with displacement and vectors in 2D and 3D. Let's go to acceleration in 2D and 3D. This is a really important topic because we will see here that the acceleration vector is not necessarily in the same direction as the velocity vector. And that will be important when we go, for example, to graphing or to determining or to plotting the acceleration and velocity vectors for a particle moving in space. Okay, so that will be the discussion of this session, of this particular section of the discussion. So the average acceleration vector is the rate of change in the velocity over a time interval. So for example, similar to our definition in 1D, the average velocity is just the change in velocity per time. So, and here, the average velocity, dito mo na makikita yung definition ng average velocity na it can be change in magnitude or change in speed, and also it can be a change in direction. Because if you change your direction, the unit vector associated with the vector that you have changes also. So technically, nagbago yung vector mo, yung velocity vector mo, kahit hindi nagbago yung speed. Okay, because you change your direction, there will be additional I hats or j hats. The components will also change. Therefore, there will be an acceleration in the direction of the motion. Okay? So for example, if this is the velocities V1 and V2, so we see here that the velocity vector is tangent. In that case, these are instantaneous velocity vectors for a car moving or rounding along a curve. So our V1 here is the tangent or the velocity vector tangent to the curve at this point P1, and our V2 here is another vector that is tangent to the curve at point P2. So ang nangyayari dito, bumabagal, it slows down, the particle slows down, the car slows down, and therefore the length of the vector initially is longer. In that case, V1 has a larger magnitude than V2. Kaya mas mahaba si V1 kay V2. Okay? So ano mangyayari? So when you, of course, you can create coordinates from that. And what we can do here is, parang kumbaga palalapitin ko tong vector na to, itong vector na to palalapitin ko dito. So this vector here, if I-approach ko papunta rito and say that, okay, I'll get something like this. So this vector here, and we have V1 and V2. So this V1 here is in this direction. Nag-drawing ako ng coordinates sa parallel sa V1. Nag-drawing ako ng coordinates sa parallel sa V2. So pinagalaw ko siya dito. And as I said, para mahanap mo yung difference between two vectors, isipin mo lang na starting from this vector and ending from this vector, what should be the position of another vector such that I'll get this vector here. So this is V1, this is V2, and the vector now, medyo mahaba itong V2 ko dito, it should be this one. So from V1, pupunta ako kay V2, this must be may change in velocity, delta V. Okay? Kaya ganyan siya. So isipin nyo lang na gano'n, mag-yun lang isipin mag-flip-flip ng signs. Isipin nyo lang, anong vector yung kailangan kong idagdag kay V1 para makuha ko si V2. Yon. So what is the vector from the tip of V1 to the tip of V2? That is the difference, delta V. And then, because delta V now is in this direction, and we see that the average velocity is also in the direction of delta V. Note here, delta V siya, hindi necessarily V. Okay? Magkaiba yan ha. Delta V ito ay V. So, baka kayo malilito, ang average velocity vector, ang change in velocity, parallel siya with average velocity, average acceleration. But the velocity per se is not. Okay? And hence, the instantaneous velocity vector and the acceleration vector, they are not necessarily parallel to each other. Kaya may ganyan ka. Kung napansin mo, V1 and V2, hindi siya parallel with A. But the delta V is parallel with A. Questions? So, may tanong?
None so far.
Okay. I hope this is clear. Medyo nakakalito to once you start drawing. Medyo nakakalito siya. So, again, when the acceleration is parallel to the velocity, the acceleration will have the tendency to change the magnitude of the velocity, or it changes its speed. So, for example, here, if delta V here is parallel to V1, for example, and V2, kung parallel yung V1 tsaka V2 na yan, ang gagawin lang ni acceleration ay pabilisin o pabagalan yung particle. Okay? So that's a change in speed or change in the magnitude of the velocity. However, if the particle, if the velocity changes its direction, so for example here, V1 and V2 have the same length, therefore same ang magnitude nila, but there is a change in the direction of the velocity vector, and hence, the tendency of the acceleration is to change the direction of the velocity. So, again, ang assumption dito ay perpendicular yung acceleration sa velocity. In summary, if A is parallel to V, then A changes magnitude of V. Okay? Whereas if A perpendicular to V, then A changes the direction of V. Okay? Kung purely parallel ang direction ng acceleration vector sa velocity vector, then ang nagbabago lang ay speed. Kung purely perpendicular, ang nagbabago lang ay direction. What if parehas? So in that case, if the acceleration and velocity vectors are neither parallel nor perpendicular to each other, some angle therefore, there's some angle between them, in that case, there is a component of the acceleration that will change the speed or the change in the magnitude of the velocity of the particle. And there's also one component of the acceleration that will change the direction of the particle. Okay? Questions? Huwag malilito ha, huwag malilito. May tanong ba rito?
None so far.
None. Okay. Now, so this is an important note. The displacement and velocity vectors are parallel to each other, but the velocity and acceleration vectors are not. So yun, hintayan paano kayo magdodrawing ng position ng velocity and acceleration vectors for a particle moving in space. Okay? Questions? May tanong ba rito?
None so far.
None. So there are other things that we can also determine. We can also use our vectors in solving the acceleration vector. So for example, here the instantaneous acceleration vector is the instantaneous rate of change of velocity. If there's a second time derivative of the position vector with respect to time, or just the time derivative of your instantaneous velocity with respect to time. So yun lang yung average acceleration. In Cartesian coordinates, you can always distribute the time derivative to the components. Parang ginawa natin kanina sa velocity. Ganun lang din siya. Now, the components are just basically the components of the vector in the direct so you perform the time differentiation per component. Per component yung time differentiation mo. So, kaya makakita ka ng average acceleration vector, or sorry, instantaneous acceleration vector in components axi hat plus ayj hat plus azk hat. And then, the magnitude is just, again, you use your Pythagorean theorem for the magnitude of the instantaneous acceleration vector. Ganun lang din siya kagaya ng sa velocity vector. Okay? Questions? May tanong?
None so far.
None. So here, this is a geometric interpretation of the instantaneous acceleration vector. So ang nangyayari, pinapalapit mo ngayon si velocity vector kay dun sa final velocity to instantaneous velocity. So in that case, ang lalabas, pag pinalapit mo siya ng pinalapit, yung limit nung vector difference silang dalawa, yun yung, and you divide it by some change in time, that is your average acceleration, or sorry, di pala average. That's the instantaneous acceleration vector or the acceleration vector at that particular point. Okay? That's the instantaneous acceleration vector. Okay. So the acceleration vector can be decomposed in terms of its parallel and its perpendicular components. Ano ibig sabihin yan? So if you have some vector A, as I said, if the vector is purely parallel to V, mas madali kasi intindihin to kapag parehas instantaneous eh. If the instantaneous acceleration A is parallel to the direction of V, then the particle will change its speed, or the particle speeds up or slows down. Kung parallel yung A at saka V vector, or if A parallel and V vector are in the same direction, bibilis yung particle. Pero kung opposite direction sila, the particle will decelerate, mag-slow down yan. Mag-slow down yung particle na yan. Now, if there is a perpendicular component here, the perpendicular component will change the direction of the particle. Kaya ang mangyayari sa kanya, mag-curve siya in this path. Now, here's an important idea when you draw your acceleration and velocity vectors. Kung halimbawa ang trajectory ng path mo ay paganyan, may ganyan kang trajectory, the acceleration vector should be lagging inward. So for example, let me use a different color. Hindi ka dapat magkakaroon ng acceleration at velocity vector sa paganyan. Kasi palabas siya, mali yan. Ang velocity vector mo dapat paloob. Paganyan. Ang acceleration vector mo dapat paloob. Ang velocity vector, I'll use another color for my, let's say I have blue here. The velocity vector is parallel, is tangent. So ganyan. Ganyan siya, ganyan siya. That's the velocity vector. Whereas the acceleration vector is always inward the curve. Inward yan lagi. Inward. Okay? Questions? May tanong ba rito?
None so far.
Okay, sige. So, okay. So, the perpendicular component is one that's normal to the path. The parallel component of the acceleration is one that is parallel to the path. Okay? Questions? Let's have an example here. We determine the direction of the acceleration vector at each point. So here, bakit naging ganito yung direction acceleration vectors? So paano muna hanapin yung velocity vector? So I'll be using green as my velocity vector. Sorry, blue pala yung velocity vector ko. Yan. So ano yung direction of velocity vector? The direction of the velocity vector is tangent to the direction of the curve. So dito siya tama. Sorry. Mali sinabi ko kanina. Okay, let me correct that. Dapat fastest siya at the lowest point. So dapat ito pinakamalaking vector. Tapos bumabagal, medyo mabagal siya, mas maliit dito, tapos pinakamalit dito. Tapos biglang liliit ulit dito. Sorry for that. Okay. Ulit. So, the velocity vector is fastest at point E, it's slowest at point B and point A. Ngayon, kung napansin mo dito, pangit, ganyan. Kung napansin mo dito, since pinakamabilis siya at point E, mas malaki yung component na to dito. Therefore, you expect that the acceleration vector, since bumibilis siya, yung direction dapat ng acceleration vector dito is in this direction. So, I'll be using green for my this one. Pag ganito siya dapat. Tapos dito, pagitna. Dito, pabalik. Kasi bumabagal ka. Bumabagal ka, therefore, kasi yung component mo ng acceleration in the parallel to the velocity is anti-parallel na sila. Kaya, bumabagal ka rito. Anti-parallel yan, no? Anti-parallel yan. So yan. Dito, parallel. So if you draw a normal line here, there will be a component that's changing the direction of the particle. There is a component that will increase the speed of the particle. Kaya ang total net acceleration mo ay dapat pa ganito. Okay? So also here, medyo bumibilis lalo. So, ganyan. Okay? Nakuha to. So the green here is the direction of the acceleration vector or the instantaneous acceleration vector, whereas the blue or the dark blue is the direction of the velocity vector. Okay? Questions? Questions?
None so far.
None. So ganun mag-drawing ng instantaneous acceleration vectors. Okay. Sige. Now let's, we still have 5 minutes.